On a windy day, a modern wind turbine can look almost unreal. Its blades sweep slowly above fields, coastlines, or open sea. It is taller than many skyscrapers. Inside, sensors constantly adjust its position. Electricity flows from a machine that, at first glance, seems remarkably simple. The wind turns blades. The blades drive a generator, and power enters the grid. But that elegant machine belongs to a much older story. For thousands of years, people have looked at moving air, flowing water, sunlight, forests, and the heat beneath the ground, and asked a practical question. How can nature do some of our work for us? Long before coal-powered factories and oil-powered cars, renewable energy was not an alternative. It was everyday life. Wind moved ships across oceans. Water turned grain mills. Wood heated homes. Sunlight dried crops. Human societies depended on energy sources that renewed themselves because there were few other choices. The modern, renewable energy movement is therefore not a return to some lost past. It is a reinvention. Old natural forces are being combined with new materials, digital control systems, massive infrastructure, and a new urgency: the need to produce energy without destabilizing the climate. This is the history of renewable energy, from windmills to solar farms. For most of human history, energy came directly from muscle, animals, firewood, wind, and water. The earliest major energy revolution was probably fire. Burning wood gave people warmth, protection, and a way to cook food. It allowed humans to survive in colder places and reshape landscapes. But wood had limits. Forests could be cut down faster than they regrew. Dense cities could suffer from smoke and fuel shortages. As populations expanded, the search for more reliable energy became increasingly important. Wind was one answer. Sailing ships transformed human history because they allowed wind to move people and goods over enormous distances. Trade routes expanded. Empires connected distant territories. Exploration accelerated. A sailing ship was, in effect, one of the most advanced renewable energy machines of its age. Windmills came later, but they extended the same principle onto land. Early windmills appeared in parts of Central Asia and the Middle East, where they were used for practical tasks such as grinding grain and pumping water. Over time, windmill technology spread into Europe, where it became a familiar part of rural life. In the Netherlands, windmills became especially important. The country's relationship with water made them more than grain processing machines. Dutch windmills helped drain wetlands, pump water, and reclaim land from the sea. They powered sawmills, oil presses, paper mills, and other early industries. This is an important point in the history of renewable energy. Wind power was not always small-scale or picturesque. In some places, it was central infrastructure. It shaped economies and landscapes. Water power was even more widespread. A watermill uses the movement of a river or stream to turn a wheel. That turning motion can grind grain, saw wood, hammer metal, or power machinery. Ancient civilizations used water-driven devices, but watermills became especially important across Europe, Asia, and the Islamic world during the medieval period. For centuries, the sound of flowing water was linked to production. A mill by a river could save enormous amounts of human labor. Instead of people grinding grain by hand, the river did the turning. Instead of workers endlessly lifting and striking materials, A water wheel could drive mechanical systems with far more consistent power. In some ways, watermills were early factories. They concentrated energy in one place and connected it to tools. They allowed work to be organized around machines rather than solely around human bodies. But wind and water were unpredictable. The wind could stop. Rivers could run low or freeze. The best sites were limited by geography. A growing industrial economy wanted energy that could be used almost anywhere, at any time, and in increasing quantities. Coal provided that. By the 18th and 19th centuries, coal transformed the world. It powered steam engines, factories, railways, ships, and cities. Unlike wind and water, coal contained stored energy that could be burned on demand. It was dense, transportable, and increasingly cheap. The Industrial Revolution was built on this advantage. Coal freed factories from rivers. Industry no longer had to cluster around watermills. A factory could be placed near workers, ports, mines, or markets. Steam power created new possibilities for manufacturing, transportation, and warfare. But the price was enormous. Coal mining was dangerous. Cities filled with smoke. Industrial pollution damaged health and landscapes. And, though people did not yet fully understand it, burning coal released carbon dioxide into the atmosphere on a vast scale. Oil and natural gas later expanded the fossil fuel age. Oil powered automobiles, aviation, modern warfare, and global trade. Natural gas became important for heating and electricity. Fossil fuels made modern industrial society possible, but they also made it dependent on resources that were finite, geographically concentrated, and environmentally damaging. For a long time, renewable energy was pushed to the margins. Windmills remained useful in farming and remote communities. Hydropower expanded, especially where major rivers could be dammed. But in the public imagination, the future belonged to coal, oil, gas, and eventually nuclear power. Then the 20th century began changing the conversation. One of the first major turning points was electricity. Electricity did not create renewable energy, but it changed what renewable sources could do. Instead of using a water wheel directly to grind grain, a turbine could generate electricity and send it through wires. Energy could be produced in one place and consumed somewhere else. Hydropower became one of the first renewable sources to enter the modern electrical age. Large dams were built across rivers in many countries. Water stored behind the dam could be released through turbines, generating electricity. Hydroelectric projects provided reliable power, flood control, irrigation, and, in some cases, national symbols of industrial progress. But dams also had consequences. They altered ecosystems, blocked fish migration, changed river systems, and sometimes displaced entire communities. Renewable energy was not automatically harmless. The history of energy is full of trade-offs, and hydropower made that clear. Solar power followed a different path. Humans had used sunlight for heat for centuries. Buildings were designed to capture winter sun or avoid summer heat. Food was dried in the sun. Water could be warmed by sunlight in simple collectors. But turning sunlight directly into electricity required a scientific breakthrough. In the 19th century, scientists discovered the photovoltaic effect. Certain materials could produce an electrical current when exposed to light. For decades, this was more of a laboratory curiosity than a practical power source. Early solar cells were inefficient and expensive. The technology found an early purpose in space. Satellites needed a reliable energy source. They could not depend on fuel deliveries, and they operated above Earth's atmosphere where sunlight was abundant. Solar panels became ideal for this environment. In the space age, solar power proved that it could work reliably under demanding conditions. The challenge was bringing that technology down to Earth at a cost ordinary people and businesses could afford. The modern renewable energy movement gained momentum in the 1970s, when the world experienced major oil crises. Energy suddenly became a political and economic problem in a new way. Countries that depended heavily on imported oil discovered how vulnerable they were to price shocks and supply disruptions. Renewable energy began to look less like an environmental curiosity and more like a strategic necessity. Governments funded research into solar panels, wind turbines, geothermal energy, biofuels, and energy efficiency. Some early projects were expensive and technically limited, but they created the foundations for later progress. Wind power, in particular, began its modern revival. The old windmill had been designed for mechanical tasks such as pumping water or milling grain. The modern wind turbine was designed to generate electricity. Its blades turned a rotor, which drove a generator. As materials improved and engineers learned more about aerodynamics, turbines became larger, more reliable, and more efficient. Denmark became one of the early leaders in modern wind energy. Its experience with windmills, engineering culture, and energy policy helped create an industry that would later become global. Other countries followed, building wind farms on land and eventually offshore. Offshore wind was a major new step. The winds over the sea are often stronger and steadier than those on land. Offshore turbines can also be larger, though building and maintaining them is more difficult. What began as a niche technology became a major part of energy planning in coastal countries. Solar power was also changing rapidly. For much of its history, solar electricity was too expensive for widespread use, but manufacturing improved, production scaled up, costs fell, panels became common on rooftops, warehouses, schools, farms, and eventually in vast utility-scale solar farms. A solar farm is one of the clearest symbols of the new energy era. Rows of panels stretch across land, quietly converting sunlight into electricity. There are no fuel trains arriving every day, no smokestacks, no combustion inside the panels themselves. But solar power has its own challenge. It produces most when the sun is shining, not necessarily when demand is highest. That brings us to one of the central problems in renewable energy. The question is not simply whether wind and solar can generate electricity. They clearly can. The harder question is how to build an energy system around sources that vary with weather, season, and time of day. A fossil fuel power plant can usually burn more fuel when demand rises. A solar panel cannot make sunlight appear at midnight. A wind turbine cannot produce power when the air is still. This is why renewable energy is not just a story about generation. It is also a story about storage, transmission, grids, and flexibility. Batteries have become increasingly important because they can store electricity produced at one time and release it later. Large grid-scale batteries can help balance supply and demand. Home batteries can store rooftop solar power. Electric vehicles may eventually play a larger role in this broader energy system as well. Other forms of storage also matter. Hydroelectric systems can sometimes pump water uphill when electricity is abundant, then release it later to generate power. Heat can be stored in certain materials. Hydrogen can be produced using electricity and potentially used later as fuel or industrial feedstock. No single solution will do everything. Different places will use different combinations of technology. A country with large rivers may rely more on hydropower. A sunny region may build solar farms. Windy coastlines may invest in offshore turbines. Areas with volcanic activity may use geothermal energy, tapping heat from beneath the Earth's surface. Agricultural regions may use some forms of biomass, though these come with difficult questions about land, forests, and food production. The renewable energy transition is therefore not about replacing one fuel with one new machine. It is about rebuilding an entire system. That system includes power lines. For decades, electricity grids were designed around large power stations, coal plants, gas plants, nuclear plants, and major dams. Renewable energy changes that pattern. Solar panels can be installed on millions of roofs. Wind farms may be far from cities. Electricity may need to travel across regions to balance different weather conditions. A modern renewable grid needs to be smarter, more connected, and more responsive than the grids of the fossil fuel age. Digital technology has become part of this story. Sensors monitor turbines. Software predicts wind and sunlight. Grid operators balance supply and demand in real time. Smart meters can help households shift electricity use toward times when power is abundant. In that sense, the future of renewable energy may depend as much on information as on engineering. The politics of renewable energy have also changed. For years, critics argued that wind and solar were too expensive, too unreliable, or too small to matter. In the early stages, there was some truth in the cost argument. Many renewable technologies depended on subsidies and policy support. But as deployment increased, costs declined dramatically. Manufacturing scale, improved design, better supply chains, and years of learning made solar panels and wind turbines far more competitive than they once were. This is one of the most important lessons in the history of technology. A machine does not have to be perfect at the beginning to become transformative. It has to be useful enough to improve, and it has to be supported long enough for learning and scale to take effect. Renewables also gained urgency because of climate change. Scientists had understood for decades that greenhouse gases trap heat in the atmosphere. As the effects of a warming planet became harder to ignore, energy policy became inseparable from climate policy. Extreme weather, rising sea levels, droughts, heat waves, and changing ecosystems made the consequences of fossil fuel dependence more immediate. Renewable energy became central not only because it could provide power, but because it offered a path toward reducing emissions. That does not make the transition simple. Wind farms require land, materials, roads, and transmission lines. Solar farms require space and large-scale manufacturing. Mining is needed for metals used in batteries, grids, and electrical equipment. Communities can disagree about where projects should be built. Jobs tied to coal, oil, and gas can be disrupted. Energy systems must remain affordable and reliable while they change. A serious renewable transition has to acknowledge these tensions rather than pretend they do not exist. But it is also important to remember what is being replaced. The old energy system has never been free of consequences. Coal mines scar landscapes. Oil spills damage coastlines. Gas leaks release methane. Air pollution from fossil fuels harms human health. Fossil fuel infrastructure has shaped geopolitics, conflict, and economic dependence for more than a century. Every energy system has costs. The real question is which costs a society is willing to accept, and whether the benefits can be shared fairly. There is something fitting about the shape of this history. Humanity began by relying directly on the forces around it: wood, wind, water, and sunlight. Then, industrial society turned toward fuels dug from the ground, using ancient stored sunlight in the form of coal, oil, and gas. That choice created extraordinary prosperity, but also deep dependence and a changing climate. Now, technology is allowing societies to use the immediate flows of nature again, though on a scale and with a sophistication earlier generations could not have imagined. The windmill has become a turbine taller than a tower. The water wheel has become a hydroelectric dam and turbine system. The sun-warmed roof has become a solar panel connected to a global supply chain. The village mill has become a digitally managed grid. Renewable energy is sometimes presented as a clean break from the past. In reality, it is a return to an old idea. The environment around us contains useful power. What is new is the scale of the ambition. The goal is no longer simply to grind grain, pump water, or light a remote building. The goal is to power cities, transport, industry, homes, and entire economies while reducing the damage caused by the energy systems that came before. Whether that transformation happens quickly enough will depend on more than turbines and panels. It will depend on investment, public trust, political decisions, new grids, storage systems, skilled workers, and the willingness to treat energy not as an invisible background service, but as one of the defining choices of modern civilization. The future may not look like the old image of renewable power, a single windmill turning quietly in a field. It may look like a vast network, a rooftop panel sending electricity into a neighborhood grid, a battery storing power for the evening, an offshore wind farm feeding a distant city, a dam balancing the system, a transmission line crossing a border, a factory using electricity instead of fossil fuels. The history of renewable energy is still being written, but it began with a simple human instinct: to notice the forces already moving through the world, and to find a way to put them to work.